Next, number 5. Add the degrees. So here's 1 plus 3, that's 4. Even. You're going to enjoy even functions. All right, your x-intercepts. Well, that one's easy. So each part, so this part right here, it doesn't have a set of parentheses, but it is by itself. So here we have x equals 0. And then we have x equals a positive 4. Ooh, look at that 3. That has a multiplicity of 3. So that multiplicity of 3, I'm going to write it over here. That multiplicity of 3, we call that a flex. I call that a wiggle. So you'll see whatever I reference it to is how you should be drawing that. All right. So the real name for it is a flex. How it should look is a wiggle. Okay. All right. Our y-intercept. So 0 for x values. Ooh. It's not f of x. It's m of x. So m of 0 equals 0 times negative 4 raised to the 3rd power. You don't even need a calculator for this. Any number times 0 is 0, so your y-intercept is 0, 0. Okay? All right. Your leading coefficients. So looking at the coefficients of x, positive 1s. So positive. This, again, is an even function. So it's positive, even. Even means they end in the same direction because it's a positive leading coefficient. They end in the positive direction. All right. So positive. So I can start with that. Positive. 0, 0 is one of my points. Oh, look, my y-intercept is also my x-intercept. Nice. And then I have a positive 4. I'm going to say 4 is somewhere over here. All right. So this is a great example of where you don't really need to label your x-intercepts. All right. So 0, 0 is sort of kind of obvious. And then the other one, you only have one more x-intercept. And because you've listed it, I can figure out that this is 4. All right. All right. So excuse me, what's this going to look like? At x equals 0, it just goes through this point. So I drew this all the way over here. I could move it over, but for the folks that want to see what that would look like, you're just going to bring that all the way over here. It goes through 0, 0, right, because it has a multiplicity of 1. Here we have to talk about what a wiggle would look like. All right. So it depends on where it's coming from. All right. So a wiggle really looks like a cubic. Oh, if I can spell. Cubic function, it has that little wiggle like that. All right. Your x-intercepts, where you want your x-intercept to be, is right in that middle of the wiggle. Okay, so it's really that turning point at the wiggle. You do want to see a little bit of a horizontal-ish section, so it doesn't just look like it's going through as if it had a multiplicity of 1. All right, so sometimes it does take a couple wiggles to sort of kind of wiggle this out, because I know it's down the polynomial is down here. I know that I'm going to need a wiggle that looks like that, all right, because it has to end upwards, okay? So my wiggles, it takes a couple tries, but I tend to go in the direction that will help me draw it. So, ooh. That does not look that great, so I'm going to try this again. Maybe if I try this way. One more time. So, like that. Okay, that looks much better. Okay, so just connect it. Great, wonderful. All right, so again, it just has to look a little bit slightly different. You'll notice that here, I tried to make this a little bit more horizontal, not as vertical as if I made this line just go through like that. Okay, so that's how I would like to show you my wiggle. Okay, some people I've seen very much like accentuate it. So if you would like to accentuate it so that you can show me that there is a wiggle, some people do it like that. All right. In real terms, it wouldn't be so horizontal for so long in this section right in the middle, okay? But because it is a sketch and because you want to show other people that it is a flex, that's the correct terminology, some people will accentuate that horizontalness in the middle, all right? All right, that's number 5. All right, moving on to number 3 and number 6, and then we are almost done. All right, number 3, the degree. Ooh, this one has a lot. 1, 1, 1, 1. That's 4. X-intercepts, 0. Ooh. X equals 0, X equals 2, X equals 4, and X equals 6. Great. Your y-intercept. Oh, that one's easy because remember this is 0. 0 times any number is 0. So 0, 0. Great. Okay. Your leading coefficient. This one's a little bit easier because it is in factored form where all of your x has a coefficient of 1. So really you're just looking at this first sign right here. So that would give you a negative coefficient. Your degree is 4, so this is an even polynomial. Because it is even, it ends in the same direction. So that means they should all be going down. So down, down. Okay, so negative infinity, negative infinity. Okay. Down. Oh, my screen just spazzed for a second. Sorry about that. So down, down. Key points, 0, 0. This looks like 2. This looks like 4. And this looks like 6. Beautiful. All right. This is all nice because it has a multiplicity of 1. So really, it's just going through those points. So this end behavior right here is a little far off. So I'm going to just make another one. Goes through 0, 0. Comes back around, goes through 2, goes back through 4, and it goes through 6. There you go. Erase my original reference for my end behavior. And